Hi students, so in this video I'm going to solve the problem in which a lift cage with mass 500 kg accelerates vertically upwards from rest to a velocity of 6 meters per second in a distance of 12 meters. The frictional resistance to the motion is assumed to be constant throughout at 200 newtons. You have to calculate the work done raising the lift, calculate the tension in the lifting cable, and calculate the power developed by the winch. Now, for the aid of solving this problem, I will be drawing a small diagram. So I have my winch here, which raises my mass of 500 kilograms up to a height of 12 meters. So that's the final resting place of my mass. We have to calculate excuse me, we have to calculate the work done excuse me, we have to calculate the work done in raising the lift. So when you have a mass being raised by a height by a winch, you have some sort of work done. So how do you solve a problem like this? Before you go about solving it, first of all we make a note of all of the given data. So we have here the mass, which is equal to 500 kilograms. The height at which it is raising is distance s equals to 12 meters. And the frictional resistance to motion, friction, is 200 newtons. Calculate the work done raising the lift. Now, how do you calculate work done? So we have to refer to our formula sheet. Under work, power, energy and forces, work done is given as force times distance. So I'm going to use my formula. Work done equals to force times distance s. I'm going to write the distance. Now this force here involves two forces. One is the force that is needed to lift the object, and the second force is the frictional resistance. So when you have a cable, this is a mechanical system, when you have a cable over here which is being pulled, you will have some sort of a frictional resistance. So this force can be split into two forces, that is force to do work plus force due to friction, and all this is multiplied by the distance s. Now we have to calculate the force due to work. Force can be calculated as, again we take a look at the formula sheet. Force equals to mass times acceleration equals to mass times acceleration. We have the value of the mass, but we don't have the acceleration. So for here we again use the formula book and we take a look at the Suvat equations, which are here. Equations of linear motion with uniform acceleration. V equals to u plus at, s equals to ut plus half at squared, v square equals to u square plus 2as, and s equals to half u plus v times t. We are going to use these equations to solve this problem. So first of all, if I take a look at my equations, I can't use the first one because I don't have the value of time. I can't use this equation because I don't have t. Same reason I can't use the second one as well, but I can use the third one because I have the final velocity, I have the initial velocity, Acceleration is what I got to find out, and I have the distance with which the load travels. So I'm going to use the third equation. So v square equals to, now I'm doing all this to find acceleration. V square equals to u square plus 2as. Now v square velocity is 6 meters per second. So v is 6. U squared is 0 because the velocity. Now a lift cage with mass 500 kilos accelerate vertically upwards from rest, and that is why my u equals to 0 meters per second, because it is at rest. A is what I got to find. My distance s is 12 meters. That's 0 plus 2 times a times s is 12. So here I make a my subject and I find the value of a. So that's going to be equals to 2 times 12 is 24a. Whenever you have constants being multiplied by variable, which is acceleration here, which is what we got to find, we write the constant first followed by the variable, equals to 6. This is v squared, so this is 6 squared, and hence this is 36. So that's 6 squared equals to 36, and hence my a will be equals to 36 over 24, which is going to be equal to, calculator, 36 divided by 24 will be equals to 1.5 meters per second squared. That's my acceleration value. Now using this acceleration, I now find my force to do work. So my force equals to mass times acceleration. My mass is 500 kilograms to do work. 500 times acceleration is 1.5, and hence my force to do work will be equal to 500 times 1.5 is 750 Newton. So I have my force due to work done. Now my force due to friction is given to us as 200 Newton. So my work done, I'll keep this here, which is A. Work done will be equal to force due to the work done, which is 750 bracket, plus my frictional force, which is 200 newtons, times the distance s, which is 12 meters. So this is going to be equal to 750 plus 200 times 12. Again, open bracket, 750 plus 200 times close bracket 12. 11,400. That's 11,400 joules of work done. Next we find the B part, which is calculate the tension in lifting the cable. So whenever we have a cable lifting a weight, it will have a tension force. And this tension force will be equal to the force due to the weight due to the weight of the mass plus force due to work done. So now the force due to the weight of the mass will be equals to mass times acceleration, which is by the formula in our formula sheet. Now the force due to work done is the total work done, which we calculated in the last part. Total work done plus the frictional forces involved, because there is a frictional force involved here. So force due to friction. So I'm going to substitute the values now. Mass is 500 kilograms times acceleration is acceleration due to gravity, which is 9.81 meters per second. Don't need to write the units. 9.81 plus force due to the total work done, which is 750 plus force due to friction, which is 200 Newton. So this is going to be equal to, getting my calculator, 500 times 9.81 plus 750 plus 200, 5,855. So 5,855 Newton. So this cable here, when lifting this object, will experience a tension force, a total tension force of 5,855 Newton. Now this here is my B part, tension force. Now we'll go about solving the third part, which is calculate the power developed by the winch. Now this power developed by the winch is equals to work done. Power in itself is work done per time, per unit time, over time. Now the work done, we have just calculated as 11,400 joules. We need time. So how do you find the value of time? So for this, we again revisit our SUVAT equations and we find the value of time using one of these equations. So I am going to use the second equation here, S equals to ut plus half at squared. So using SUVAT equations, S equals to ut plus half at squared. My distance is 12 equals to initial velocity is 0 times time plus half, I'm going to write as 0.5 acceleration value is 1.5 meters per second square times t squared. Now I don't know the value of t, so I'm going to write t squared. So this is going to boil down. This is going to boil down to 0. So 12 will be equals to 0.5 times 1.5, 0.5 times 1.5 is 0.75 t squared. 12 divided by 0.75 will be equals to t squared. 12 divided by 0.75 will be equals to 16 equals to t squared, and hence my t will be equals to square root of 16. When the square goes on the other side, it goes as square root, and my square root of my answer, which was 16, is 4. So hence my time t equals to 4 seconds. And hence my power will be equals to work done, which is 11,400. So 11,400 over time t is 4 seconds. That's going to be equal to 11400 divided by 4 will be equal to 850 watts. So power will be equals to 2850 watts. That's my C part. Let me highlight all of my answers. So that's my power. Tension force is 5855 Newton, and my A part is 11,400 joules. It's a good practice to highlight your answer. So this way, when your work is marked in your exam, the examiner it's easy for the examiner to look at your answers, and that way you'll be awarded the maximum marks. So please make a habit of highlighting your answers. So I have now calculated the work done in raising this object, the the tension force that this cable is going to feel, and the power needed to raise the power which is needed to raise the object up to a height of 12 meters in 4 seconds of time. So now what I want you to do is close this video, make a note of this problem, and try solving it without looking at the video. Good luck.